Hi, Electric Roo here again. Welcome to my workbench. Today I want to talk about a tube amplifier that I built in the past. At the beginning of this year. I think I finished it late fall. It's a 6v6 push-pull amplifier. It's sitting there over my left shoulder. This circuit was a little bit different. I did have another 6v6 that I had built, and I actually sold that one. It was a simple circuit based on that Dynaco 6v6 that a lot of people have built, but I thought I could do better. This one is based on Audio Note Kit 4, which they had discontinued for some time now, but I liked the circuit and I thought I would build it, and it sounds pretty good. And now you might ask, why a 6v6? I've always had a soft spot for the 6v6 for the sound, so I decided to do that. And it's interesting to note that if you look back at some of the amplifiers in the days past, and I always liked what Magnavox did. For some reason they always stuck with the 6v6 tubes in their big consoles. Now they could have easily switched over to the 6L6, but I think they were onto something there. And as anyone in the field knows, that not always power is not always the answer for good stereo sound. And if you look at what Magnavox did, even in some of their bigger consoles, the most expensive one, they actually had one separate amplifier for each channel, and that amplifier contained parallel push-pull 6v6s for the bass, and then a single 6v6 single-ended for the treble. And if you hear these amplifiers today, I'm not sure how they would sound out of their environment, out of the consoles that they were designed to. I came across an email one time on the internet from a fellow that's rebuilt some of these amplifiers, and somehow he had contacted and got in contact with a gentleman who actually did work for Magnavox back in the day, and his comments on the whole scheme of things of what they did was they designed from A to B in those consoles. So if there was a shortcoming in the phono cartridge, they compensated it somewhere else in the circuit. As a shortcoming in the amplifier, they compensated for it elsewhere. And so with the speakers, that's how they maintain the sound. I'd really like to hear one of those big consoles. I've never had the opportunity to do that yet. But with this amplifier, I'm pretty impressed with it, and it looks good and it sounds good. So let's get it over here on the workbench, and I'll talk about it a little more. We can open it up and we'll see what I did, and I'll give you some tips on how I do things and what I did to already change it. I did make some improvements. I plan on making some more improvements, but let's go over there and take a look. Alright, we're up here on the workbench. That's my technical advisor, Ivan. He's always got his nose in things. And let's take a quick look at the top of the amplifier here. This thing uses, as I said, it uses push-pull 6v6s in the output. And we have some 6SN7 as drivers, and preamp is 12AX7s. Now this chassis was quite interesting. I wanted a really nice looking chassis, so I bought this one from our friends over in China, and I got more than I bargained for, because this thing is thick. If you look how thick this chassis was, you can imagine it was a real bugger getting the holes in for the tube sockets and everything else, because it was so dang thick. I had to buy a set of carbide bit hole saws with the carbide cutters on them to do that right. And the transformers, I always go with oversized transformers no matter what I'm doing. I figured it can hurt, and it's higher power levels, less saturation in the transformer itself. These are actually overkill for the 6v6s. Those 6v6s there are the 6v6 GTAs, which are rated at 14 watts. But these transformers are 24 or 20 watt output transformers. Now, one of the reasons I wanted to do another 6v6 is, if you remember, or anyone out there, you guys are familiar with the guys from Acra Sound and Dyna, David Helfer, I'm probably not pronouncing it right, and Kuros. They did a lot of extensive tests when they built their transformers. And this is an ultralinear amp, so it uses the ultralinear taps. But they did tests, and they determined that on the 6v6, the ideal tap percentage for the ultralinear was 23%. So that's something I wanted to do, because the last 6v6 amplifier that I built actually was using the normal, standard what comes in the output transformers. But these ones aren't. These ones are tapped out at 23%. And I thought I would check that out and see how things work. So, a little better look at it there, the back and the front. I have some more things to do with it. This is the choke is sitting in here, but let me flip this guy around underneath and we'll look at the innards. Okay, we got it flipped upside down here. Let's walk over here and take a look to see what I did. Now, this circuit board, actually I bought this circuit board from it was made over in China, and the circuit is the same as the original Kit 4 with a few enhancements in the power supply, but basically it's the same exact circuit. It's even pretty close to the same original size. And originally this circuit was cathode biased, which means that you had the cathode, you had the resistor and I took these out, the cap and the cathode circuit. Here's a picture of the original print. By the way, you can see this on my website. If you go to audio.rdsrepair.com, you will see some of the amplifiers that I built. A few of them I have up there. And if you look, of course, we have the fixed bias, the resistor and cap in the circuit. And what I did was I came across these auto bias boards. If you go over to, you can see the web address on the board, www.audioamp.eu. And I think the distributor here in the United States is Erdhard Audio. But I thought I'd try that. And these boards are pretty neat. What you can do is turn an amp into fixed bias. And what that means, if you're aware of the fixed bias amps, you have to adjust the current for each tube on the bias to get it the same. And the advantage of this board is it constantly keeps the same current with the original set point. When you install this board, as I did, what you have to do is I took out the cathode resistor and cap and actually disconnected the resistor here. The original was 270K, and I put I think 120K I used, but disconnected it from the ground, and those would be the points where your bias voltage connects to from the output of this board. And once you set that, you go through the setup procedure even before you have the board in, or you can change it after, pull the tubes. You make the setting, set the current, and it's set for life. Now, one advantage of this is, especially in the tubes when they become unbalanced as they age, even in cathode bias, even so in fixed bias tubes, this keeps the current straight for each tube exactly the same throughout the life of the tube, which also has another advantage. You don't have to start out with matched tubes, matched pairs, because this board will keep things exactly the same. So they tell me. Now, being that this amplifier I had originally made that for cathode biased, I didn't have a extra tap on a transformer for the bias voltage. So this board here I bought, you can see it comes with, this one came with a transformer, which you either hook it's 110 or 220, 110 in this case, to the power, and it provides the bias power to power this board. And it actually set up pretty similar to what you do if you had a resistor in there and you were measuring your voltage across it to set your bias. This thing, these are the same setup here, each one of them then. So you put your meter across the ground before you even connect this board, or again, I see you can do it after if you pull the tubes. From the ground connection to this little pad here, right down there, let me get a pencil here and point it out a little better. This little pad, and you measure your reference voltage, then you adjust the trim pod here, and that sets each one of these for each tube. Then you can, you're set and on your way. So that way you can adjust if you want, which I'm going to try. I have this set at 37 milliamps right now, and actually it gives, with 1.5 volt on the input, I can get 11.85 watts out with a very clean waveform, which really surprised me, because the old other 6v6 amplifier that I built, if you got up to about 8 watts a channel, then you started getting distortion in the waveform. Now, as far as the actually distortion percentage of this amplifier, I don't know that yet. I actually have this project here, this ICO distortion analyzer that I want to get going. It actually fires up and everything works, but I have to check it out, maybe change a few of the old power supply caps and get it aligned. I got the manual for it, so that shouldn't be too difficult. So that worked out pretty good. And everybody's ears are different, and I understand that. And I actually, usually in a lot of the amplifiers, all the coupling caps, I like the, oh, there comes my tech advisor again. I like the Mallory 150Ps. Now, there's a lot of discrepancy on the net of coupling caps on this good, that bit, and some of them can be, well, my goodness, they're really expensive. And in this one I used the audio cap thetas, and to tell you the truth, now it's probably my ears, but I can't tell the difference between that and what I've used before. Some guys say they can. I can't tell the difference in a burn-in time in a capacitor. It all sounds good, sounds the same to me. So I don't know whether some of that snake oil they sell, I don't believe you need a really good capacitor. So you see a lot of guys that did tests on the internet, and you know, they're comparing with their own ears, but I think they're also selling some of these caps, the really expensive ones. But I've yet to see a blind test with a group of people and with different coupling capacitors. I haven't seen that yet. But I don't care what anybody says. If you got a clean waveform in, and you're getting a clean waveform out, and you're getting as less distortion as you can possibly manage out of the circuit with your test equipment, distortion meters. I know there are a lot better ones than this ICO, but hey, I'm not going to spend a lot of money on some of this stuff. But I have some friends who have some equipment, and I could actually send this to one of my friends, and he could check it out when I'm done and see what his equipment comes up. He has some good equipment. But if you got good signal going in, good signal going out, I don't see how you can possibly hear a difference. But some people have subtle changes in the ears, just like Ivan. Well, I don't know where he went. Cats can hear a lot of high frequency. We can't. So some people may be blessed with ears that can pick up these little details. Now, I know I've heard different detail on this amplifier and some of my other amplifiers that I've built from the old stuff, which wasn't there before. So maybe that is true, because right now my go-to speakers are these Bowers and Wilkins, the 603 S2s. Is that what that is? 603? I can't remember. But they're nice little speakers. And I think when a lot of guys build these, especially building amplifiers, you really want to keep in mind what speakers you're using it with. Because actually I have a set of old Radio Shack, believe it or not, the Mach 2s, which actually I guess I've read that the Mach 1s were better. They've got 15-inch woofers in them, and I actually got those. That'll be another day, because I built a solid state amp that's about 100 watts a channel, and I wanted something that could handle the power for the outside parties and such, you know. But actually these tube amplifiers that I have don't sound that well on them old Mach 2 speakers, and I think they had in mind of the circuitry of the day. And that amplifier that I built actually has some old school parts in it. That's why I built it, that solid state amp. We'll cover that another day. But anyway, getting back to the innards here, and basically it's your simple circuit. And a lot of guys complain, I know, about the drivers, the phase splitters, and there's a lot to say about that. I know some of my friends over, especially Max, who runs the Fun with Tubes website. If you're interested, he's got a lot of great results in testing of different phase splitter circuits, and he's come up with tubes in the circuits to give you a really clean output on the phase splitter. Now, the main gripe of this style of phase splitter is all things not being equal on the output. But as I did testing so far on the output of the driver tubes, and there's not a whole lot of difference in the voltage output, but I need to get that distortion analyzer hooked up to see what's going on there. And actually the circuit I have up on the web is wrong, because this resistor should be a 200 or 220K. I have to change this schematic up, put a different one up there. But other than that, you have your basic rectifier caps, and this is a Hammond 159S choke I put in there. It's actually 4 Henry at 225 milliamp. And the output, the 6SN7s and the 6V6 are running off the transformer tap, and I have the 12AX7 filaments. They're actually rectified, and usually I put a regulation circuit in, but this transformer didn't have enough voltage to, and this works out good. Actually, to get the 12AX7s within range, I think the voltage on there is 12.3 with this resistor in there, and seems pretty steady, so it gives me a little leeway. 12.3 or 12.4 I ended up with, pretty close to the 12.6, so that works out okay. And so all in all, and actually I always talk about, let me talk a little bit about grounding. In all the amps that I ever built, I never had an issue with hum. Now, I don't know whether it's me or how I set up my grounding system, because actually my whole ground is isolated through this circuit here. As you can see, you can use a full wave rectifier with a 10 ohm resistor across it and a 0.047. So you have the audio ground, which is the whole amplifier, and then the other end connects to the chassis. The idea behind that is any high frequencies of noise will be bypassed directly to ground through the cap, and you have a little bit of through the this resistor here providing some reference to ground. But the idea with these diodes, if you do have a short in the system, these diodes will conduct, and then they will pop out, so that gives you a little bit of protection too. You can look that up. I think over at the Valve Wizard he has some good information on grounding, and he has similar that setup there. But as you see, the output transformer is 8K, 23% ultralinear taps, and we can run 4 or 8 ohms off there, and I have the taps there. I think this transformer will do, or this output transformers have a 16 ohm tap, but I'm not using it. Though I did have to change one recently for a fella. I had a 6L6 amplifier that I sold, and he wanted it set up to run 16 ohms for some speakers he had, which he was real happy with it. It sounded great. Now I may do something about balancing the phase splitter a little more, put in control, but if you put a control in actually in this area here to try to balance these sections out of the phase splitter, as your tubes age, that's going to change. So I may just leave it alone depending on what the distortion analyzer shows when I get that all done. And if you have any questions about this build, you can send me an email. You can go over to the website again. That's audio.rdsrepair.com, and my email address is electricroo@gmail.com. And you can see where I put the 120K resistors in and hook them up to this board, and also the connections where I remove the cathode resistor, and the capacitor runs right into the board. So all in all, that worked out pretty good. And I always try to use a good quality filter capacitor. I think it makes a difference. Something with a low ESR, you can find them. And I like these controls. These are just volume controls, one for each channel, and it just Alps, the blue velvet they call them. And sometimes there you see a little bit of copper tape there. Those are on the input wires for shielding. I actually use that in the insides of my cigar box guitars that I build. I have a few more to finish here. That I got a 3-string bass I'm working on. I made a 2-string bass someone wanted, the fellow I sold it. Then I have a another one that is going to be a fretless slide that I haven't finished those yet either. So don't hesitate to experiment and play around with these things, but also be careful of the voltages. You can get hurt. There are high voltages in tube amplifiers. You really need to know what you're doing, and you need to give it your thought. And I kind of chuckle with some of these guys I read in the forums that said, oh yeah, I threw this amplifier together this evening, and that can't be true, because I know how long it takes and how much thought goes into how you're going to design something, and take your time and put it together right. It can take quite a while, especially if you work at it a little bit of time. So I don't believe you guys are actually throwing something together nice in an evening, because it takes a lot more time in the evening to do that, especially when you're working on a chassis, drilling the holes in it and such. I still haven't put the bottom plate on. I got it up here on the shelf, but me and my memory, I can't remember where these are metric. I'm still looking for the screws, but I also need to put a couple vent holes in it, like I have on the top of it. You saw them from the picture. I put those vents in. But as soon as I find these screws, I'll be in good shape. I've been accused of forgetting everything lately, and I might chase my tail for a while when I'm working on something, because I set a tool down and I can't remember where I put it. So if you have any questions, email me. Be glad to talk to you. And hey, I'm no genius. I'm just a guy who likes screwing around with these things. So you guys have a good day, and I'll see you in my next video.